Today we're going to look at savings plans and investments as well as payments. And we're going to use our TI-83 or our 84 to help us out with some of the calculations because some of these formulas that we're going to look at can be a little bit scary. So say, for example, you're looking at setting up a savings plan and you're making regular payments every month and you want to know how much money will be in the account after Y number of years. You can use this lovely formula. So for example, if you had an account that you were going to make payments of $100 to every month and your APR is an unheard of 12%, and you want to know how much money is going to be in that account after 6 months, we can use the very large formula for payments and amounts. So our payment every month would be $100. Our APR is 12. It's compounded monthly. Of course, we're only doing that half of the year, so we can't put 6 because that would be 6 years. The Y will always be time in years. We need to subtract out the 1. If you've looked at APY, then this will be a familiar process. Then we're going to divide our APR over N again because we're not getting the compounding on the full $600 every month, right? It's only on that one piece from before. And when we simplify some of this, we'll be able to see that in 6 months, we'll have $615.20. But this is a lot of calculation, and it's a lot of things to even type into our calculator. So what we can do is use something called the TVM solver, time value money. And we'll be able to get into that by hitting apps, and you'll want finance. For me, it's the only one that I have, and the TVM solver will be the first one. Hit enter, and this very long screen will come up. N is the number of compounds, and most likely in many of the applications, those compounds will be 12 times a year, but you're also going to have to put in for how many years. In this case, it was for half of a year, so we're only going to have 6 times that this compounds. So it says N, it really means N times Y or N times T. How many times are you going to compound this money? I, with the percent sign, is your interest rate. You do not need to change it to a decimal. Our interest rate was 12. PV stands for present value, so that is how much money you're starting out with. And if you're starting a savings plan, you're starting with no money, so we're going to leave that as a 0. PMT is payment. We're putting in $100 a month. I'm going to skip over FV for a second and go to PY and CY. That's periods per year and compounds per year. In almost every single example, it will be 12. Because you have something that you're doing monthly every year. And these two numbers will always be the same. And now I'm going to go back up to FV, which is future value. So if I'm putting $100 in a month and I'm earning interest compounded monthly, how much will I have in the 6 months? This is the tricky part. 0 is a number, so I'm going to need to clear that number out so that it's actually completely blank. And then I need to hit alpha, enter for solve, and it will tell you. Now your future value, and this happens quite frequently, will have a negative because that's what it will be. Right now you have nothing, right? Your present value is 0. So your future value is the $615.20. So a little bit easier than going through the process of using this very long formula. But the other nice part of this is, let's say, for example, you knew that you wanted to have $1,000. How much money would I have to put in every month in order to make sure in 6 months, given that I'm having a compound interest of 12%, would I have to put in? So I can put in a future value, clear out the payment, and then say alpha enter on that, and say, oh, I'd have to put in $162, almost $163 in order to hit that particular benchmark. At this point, I'm going to pull up some of the homework problems, and so that you can see the different spots that you would need to substitute some numbers in. So at age 20, somebody sets up an IRA, a retirement account. Their APR is 6%. This is going to be compounded monthly. At the end of each month, and beginning and end does make a difference. Most of the time when we're talking about these types of questions, it will be at the end. He puts $60 in the account. How much would this account have when he retires at 65? So we're talking about 45 years, every month putting in $60. How much money will he have at retirement? Or she, because it says someone. We don't know who it is. So I'm going to go up to N. And for 45 years, I'm going to do this every single month. And so there's going to be 540 deposits. The deposits get 6%. Of course, that's going to be divided up over the 12 periods per year. I'm starting out with nothing right now, but I'm going to be making payments of $60 a month. How much money will be in the account at the end of 45 years? Clear that out. You must clear it out before you solve, or the calculator gets a little confused. Alpha, enter, and they will have $165,359.56. So let's see if I can remember all of this. To type that in, I think I got an extra 3 in there. 365,359. Yes. And we'll check that out. And so that's how much money I have now, but a lot of that money is going to be interest that I've earned. So back to the main screen, 45 years, every month I put in $60. I contributed to that account only $32,400. All of the all of the other money that's in that account is interest that I've earned. $132,959. And so the total deposits, 32,400, is much less than what I've earned. Notice he was only, or she was only, putting $60 a month away. So this, once you are comfortable in your career, is not a ton of money, but if you do this for a very long time, you can see how much money you will earn, ending up with nearly $170,000, having only put out about $32,000. We can work this a little bit differently as well. We can say, well, I'm 35 years old. I want to retire at 65. So I want to work another 30 years. I want to have a retirement fund that will allow me to pull out $125,000 a year. The question is, how much money do I need to have in the account so that I can essentially live off the interest, right? And that there's going to be a base amount of money in there earning interest. And at the end of every year, or at the beginning of every year, I can pull out $125,000 like as a salary. And so I need to figure out how much money do I have to have saved up for that retirement fund. So the first part is going to be figuring out 7% of what amount is $125,000. So 7% of what number is going to be $125,000? A lot of money. Let's see, 1,785,715, and we can check this by saying, well, what's 7% of that? And we get the $125,000. So in order for me to pull out a $125,000 salary per year when I retire, I need to have well over $1 million, nearly $2 million in my account when I retire. Rounded to this nearest whole integer. Let's see if we can get all of this put in so we can see the next question. All right, so how the heck are we going to get there? That's the big question, right? That's a lot of money. So let's go back to the TV solver. And I have 30 years, and every month I'm going to put away some money. We're going to say that the 7% stays all the time. Right now it's not worth anything. I don't know what the payment is yet. I'm just going to put $1 in there to hold the spot. I know I want my future value to be 178,541.4. And so now I can go back up to payment and clear that out and say, all right, how much money do I have to put away every month if my end goal is to have that very large future value? Alpha, enter. I need to put away $1,463 and about 73 cents. So 146373. And that is how you'll be able to pull out that large salary. Now, these questions assume a number of things. One, they're assuming that you're going to put away the same amount of money every month for the entire time that you're saving, and that's pretty unlikely. Usually you save less in the beginning and more at the end, just because as you stay at a particular position or as you grow in your career, you tend to make more money. They're assuming that the interest rate will be locked in. It will never go up and it will never go down. It also assumes that there isn't any matching. And very often when you do 401ks, there's matching that takes place. There's one more question that I'd like to look at that isn't in the homework that talks about mortgages. So the mortgage questions, when and if you see them, have a little bit of a different feel because when you're talking about paying off a mortgage, your future value actually is hopefully zero, right? That you're paying off the entire value of the loan. Now, that doesn't mean the value of your house is zero. It means that you're all paid up. And that present value is going to be how much you take out for the loan. Most mortgages are for 30 years. And you need to pay every month, unfortunately. And so you're going to have to wind up making approximately 360 payments. Interest rates can vary. Right now they're about 4.1, so I'm going to put in 4.1 for my loan. And let's say that I'm taking out a mortgage for $300,000. Depending where you are in the United States, $300,000 may be a gigantic house. It may be a studio apartment. It just depends on where you live. We want our future value to be zero. We want the loan to be paid off, not that the house will be worth zero. I'm going to back up to payment, and now I can figure out how much my mortgage payments are going to be. I'll clear that out and hit alpha, enter, and your mortgage payments will be about $1,450 a month. And there's a lot that goes into how these mortgage payments are made up and what happens over time. But if you're looking for just what your payment is, this is going to be a great tool for an estimate. Of course, there's also plenty of places that you can look online. So the TVM Solver, a great tool to help you avoid using those scary, scary formulas.